Hi guys, welcome to lesson 3 where we are going to talk about geometric sequences. Geometric sequences are just like a list of numbers, just like the arithmetic sequences were. The difference is arithmetic sequence it contains like addition or subtraction as a pattern, and geometric is going to be multiplying or dividing. And we've had this before, so let's pretend like I did like 3, 6, 9, 12, dot, dot, dot. So our pattern here would be times 3. But what if we went the other direction? So what if we did, let's do like 8, and then 4, and then 2, and then 1. So notice this time, instead of multiplying by a number, I'm dividing by a number. So in this case, I'm dividing by 2. But I can't say dividing. I have to look at it as multiplication. And so this is the same thing as saying times and then 1 over whatever you're dividing by. So I don't know if you'll remember this, but we actually talked about this when we talked about exponential functions and writing their equations. So you can't do division. You always do like what you're multiplying by on the bottom of 1. So divided by 2 is the same thing as times 1/2. So that's what we would use. We wouldn't use that. Okay, and this is all to find the pattern right here. That's called the common ratio. And again, that's just the pattern that you're multiplying by. That's it. Just like the last one, that's going to be our first term. And really, those are the only two things we need, and then we can do different things with it. The last thing I want to say about this is on the EOC reference sheet, these are listed as G's instead of A's, but any textbook usually is an A. So just feel comfortable with seeing it as a G. Outside the EOC, you probably will see it mostly as A's though. Okay, so I'm going to come back to this. I want you to look at this problem right here. So I want you to figure out what you're multiplying by. So let's see, I'm going from 4 to 8, 8 to 16, 16 to 32. So I'm multiplying by 2. So my common ratio is going to be 2. Okay, now the rule, I'm going to use this formula, and you could use A sub n or G sub n, it does not matter. And let's see, our first term is going to be 4, so that's going to go there. And then times, I just like to use parentheses, the pattern, and then n minus 1. So what is my pattern or my common ratio? That's going to be 2, so that's going to be our rule. Okay, that one wasn't too bad, but this one is really yucky. Like, I don't know what the pattern is. So what do you do if you get stuck? And so that's where this comes into play. So you can choose any two numbers. So I'm going to choose these two numbers in the sequence, and you could choose like these two, or you can do these two or these two. It doesn't matter. You can choose any two. This works for anything. And what you're going to do is you're going to take this divided by that. So in my calculator, I'm going to come up here and do 1 over 27, sorry, that's a negative, over 1 over 9. And so when you do that, you end up with a negative 1/3, and that's actually going to be our pattern. So if I multiply 1/9 times negative 1/3, that is going to give me negative 1 over 27. And if I multiply 1 over 27 by negative 1/3, I'm going to get a positive 1 over 81. So our common ratio or our pattern is going to be negative 1/3. And so I'm going to put this in the formula again. Let's see, our first term is 1/9, and then times something minus n, and this is always our pattern. So it's going to be negative 1/3. Something I want you to notice about this, notice this is like positive, negative, positive, negative. That will 100% of the time mean that this is a negative common ratio. And so those are pretty common. So just make sure you're kind of on the lookout for that. Okay, notice this one. Let's see, if it's a geometric ratio, this would be times 4. This is definitely not times 4. So this is not a geometric sequence. It does not have the same common ratio. Okay, So let's look at these next two, 4 and 5. So we have to determine whether the sequence is arithmetic. So I'm looking for addition or subtraction, geometric, I'm looking for multiplication, kind of division too, or neither. Okay, so notice this one. Very first thing that I notice is this positive, negative, positive, negative. So I have a feeling that is geometric. So let's see, I'm multiplying by -2, multiplying by -2. Yeah, that works. So what I'm going to do on my calculator is I'm going to do, oops, sorry, it's just 3. I'm going to do -56 times -2. And notice I get that positive 112. Then I'm going to multiply that times -2, and I get -224. And I'm going to multiply that times -2, and I get positive 448. So those are my next 3 terms in the sequence. Okay, for this next one, it looks like I notice the numbers are getting smaller, and it looks like, let's see, I subtract 5, subtract 5, subtract 5. Yeah, so that's going to be my pattern. So subtracting is going to be arithmetic, and then I'm going to find the next 3 terms. So I'm going to take -7 minus 5 is -12, minus 5 is -17, minus 5 is -22. Okay, so now what if we have the rule, can we figure out the first 4 terms? And I feel like a lot of people just don't know where to get started with this. And once they get started, they think it's pretty easy. So what I want you to know about these rules is right here, this tells you the first part of your answer. So our first term is -1. And then I'm going to take -1 times 3. And I'm going to get -3. And then times 3 is -9, times 3 is -27. Okay, so let's do the next one. So 1/2 is our first term. So 1/2 times 4 is going to be 2, and then times 4 is going to be 8, and then times 4 is going to be 32. This number 8, I'm going to start with 2. Half of 2 is 1. Half of 1 is 1/2. Half of 1/2 is 1/4. And again, you're just taking like, and you can even do like times 0.5, times 0.5, times 0.5. That'll get you where you need to go. Okay, and then for this last one, I'm going to start with 3. I'm going to say times -5 is -15. Times -5 is positive 75. So notice the positive, negative, positive. So I already know that this one is negative. And so when I multiply that by -5, I get -375. Okay, let's keep going. Over here, so we're going to kind of transition over to more of like a Desmos space. So what you need to know is arithmetic sequences, we already talked about, make lines, where geometric sequences always make exponential functions. So that's like the exponential growth or exponential decay. And then the common ratio, so if I had like y equals 3 times 2 to the x power, like that's what the type of equation that Desmos is going to pop out. This is always the base of the exponent. Oops. It doesn't matter if we're doing it in the explicit form or just like a regular generic exponential form. The base is always going to be the same. It's always going to be the base of the exponent is going to be our pattern. Okay, so right here, if you type this in Desmos, it's going to look like this. Like our first term is 3, our second term is 6, our third term is 12, and our fourth term is 24. So that's how I'm going to type it into Desmos. And then I want you to kind of play around with that and see if Desmos can give you an equation. Okay, so if you'll notice, this is kind of hard to see. I love this this little magnifying glass. So I'm going to click on that, and you can kind of see that it makes an exponential. Make sure that when you come here, notice that this r squared, that's not equal to 1. And so we want it to be perfect. And so I'm going to go to exponential and notice that equals 1. So that means that it goes through all the points, and that's exactly what we want. Okay, so the formula that that Desmos pops out is y is equal to 1.5 times 2 to the x power. Okay, so what's nice about this is if you had something gross like that one equation with like the fractions a while ago, Desmos will actually like help you find that pattern. So remember, it's just the base of the exponent. That's not going to change. I can easily come back here and do the explicit formula because I know the first term. The first term is 3, and my pattern is 2. And so that's what the explicit formula would look like. Okay, so I want you to look at this. I just want to give you like a caveat. So if we had something like this would be the exact same explicit equation, except for this would be a -2. So remember that negative makes it like flip-flop back and forth. But if you type this into Desmos, if you did like -6 here and -24 here, do you see how it just kind of like it doesn't give you, it kind of flips out a little bit because you're not following that pattern. So just know if I were to do this into Desmos, I would just make this just normal, like 6, +6, +24, and then just know that your pattern is going to be negative. And so I think that'll get you like where you need to go. Okay, so let's go here to number 10. So on number 10, it gives us, this is actually like a release EOC type question. So it gives us, I know that the second term is 18, and I know that the fourth term is 162. So I'm going to use that to my advantage. So I'm going to create a table, and I'm going to say the second term is 18. Oops. And the fourth term is 162. Like that. Okay, and I know it's geometric, so I am just going to go here. I automatically know it's exponential. So every time it's geometric, it's always exponential. Okay, so the first thing that I notice about this is that my pattern, so look at the equation that Desmos pukes out, my pattern is 3. So I know that it can't be this one, and I know that it can't be this one. So it's one of these, but I still don't know that first term. I can guess that it's not 18 because the second term's 18, but let's pretend like I'm not for sure. So what I would do is I would copy this down and then have Desmos make the pattern. This is pretty important. So make sure Desmos makes a pattern. And then notice here, and I can put in anything I want from there, but notice how the first term, it tells us the first term is 6. So that means that it has to be B. Okay, let's go to number 11. So I'm going to, and you don't have to, you could totally do this problem without Desmos, but I'm going to go ahead and type in everything I see onto Desmos. So it looks like that. Okay, I think I'm going to go here. So write an equation for the nth term. So I'm going to start there because I think that should be pretty easy. So a sub n equals my first term times my pattern. Okay, so let's pretend, maybe you can already see it, but let's pretend that we're not so sure on the pattern. So again, it's exponential. And so my pattern is 0.5 or 1/2, however you want to look at it. Notice I'm dividing by 2. So that's, to me, like that's kind of what went through my head is the 1/2. Oops. And then I'm going to say it in -1 power. Okay, how many clicks on the zoom in button? So I'm on A. How many clicks on the zoom in button is a side length 5 miles? Okay, so I'm going to tell you this is what I would do. This is kind of a cheater way. So I'm going to go ahead and find that table. And then I'm just going to keep, because I want the Y value to be 5. And so I just don't know. So I'm going to keep hitting enter until I get down to 5. Right there. Oh, right there. So at 6 clicks, that's going to give me 5 miles. Okay, so if we kept zooming in, just kept going, would it give us to 0 or get us to 0? And the answer is no, because think about this. This is an exponential function, and So it gets, you can kind of start seeing now, it gets really, really, really close to that x-axis where x is equal to 0. I'm sorry, for y is equal to 0, but it never truly touches it. So it's impossible by the nature of an exponential function because they have that asymptote there, and you can never, like, you can always go half of any value. You're going to get really, really, really close to 0, but you're never going to truly touch 0. Okay, that is it, guys.